Welcome to this explainer. I am absolutely thrilled to have you here today. If you're a focused learner who loves breaking down complex systems into crystal clear, structured ideas, well, you're in the exact right place. Today, our goal is simple, but honestly pretty ambitious. We're going to demystify the foundational logic of how databases organize the vast, seemingly chaotic world of information. We're basically taking an anatomy lesson on the relational data model. So get ready, because understanding this, it's going to completely change how you view the digital systems you interact with every single day.
Seriously, have you ever really thought about it? Every single bank transaction, every social media post you scroll past, every online order. How does the digital world keep billions of facts completely straight, accessible in literal milliseconds, and perfectly organized? I'll tell you right now, it doesn't happen by accident. It happens through intense architectural strictness. And to understand how we actually tame all this data, we need to look back at the master blueprint that started the whole shebang.
Okay, let's dive right into this. The year is 1970. This number right here, it's essentially the big bang for modern data organization. Back in 1970, a computer scientist named C.F. Codd published a paper that introduced what we call the relational data model. Before Codd, data was stored in these incredibly clunky, complex ways that required highly specialized programming just to track down one single piece of information. But Codd stepped in and introduced a foundational technology that is literally still running our digital lives behind the scenes today. And you know what's crazy? Codd's idea was revolutionary exactly because it was so incredibly simple. He described the entire world of data just as a collection of interrelated relations, or, in plain English, tables. He realized that the immense, swirling complexity of the real world's data could be mathematically modeled just by linking neatly organized tables together. It was an absolute stroke of genius that brought order to digital chaos.
Section 1. The Rosetta Stone of Database Jargon.
So, database theory kind of suffers from a bit of an identity crisis. We have multiple, highly intimidating words for the exact same concepts. But don't worry, here is your Rosetta Stone. Take a good look at how these terms line up. In the academic world, you're going to hear the word relation, but honestly, that just means a table or a file. You'll hear the super technical word tuple, but we're literally just talking about a record or a row. And when they say attribute, they just mean a column or a field. I really want you to realize right now that these big, intimidating academic words, they're just the everyday spreadsheet concepts you're already completely familiar with. It's the exact same logic, just wearing a lab coat.
Section 2. Zooming in, the anatomy of a table.
All right, let's start with the macro structure, the relation. Think of this as our table. This is the ultimate housing unit for our information. And the core characteristic of this relation is that each row inside it represents a group of related data values. Basically, it's a unified container holding a very specific collection of facts. Now, looking at the vertical structure of that housing unit, we find columns, fields, or attributes. These really act as the principal storage units of our table. Whether it's a student ID, a student name, or a department, these columns are the defining categories. They tell us exactly what kind of information is allowed to live in this particular vertical slice of our database. Okay, let's shift our focus horizontally for a second, to the rows, or, remember our fancy word, the records or tuples. While columns dictate the category, a single record neatly packages a specific set of attributes together for one distinct entity. For example, record ID 1 relates the publication date of July 26, 1968, the author Abdullah, and the title Rights and Wrongs Online. All those completely separate fields are logically related to one another to describe one single unified book. Make sense? Moving right along, another vital measurement is the degree. In relational database terms, the degree is simply the total number of attributes, or columns, contained in a table. It's really that simple. Actually, if we look back at the table we just talked about, the one with record ID, publication date, author, and title, well, that's 4 columns. Therefore, the degree of that table is exactly 4. It's just a super quick way to measure how wide our data structure is.
Section 3. Micro level, data domains, and types.
Now we're really zooming into the micro level to see exactly how a database maintains its perfection. I want you to think of this concept, a domain, as the strict bouncer at the door of your database. A domain is a set of acceptable atomic values that a column is allowed to contain. So the absolute crucial point here is that a domain is basically a strict rulebook. It determines the specific, limited pool of possibilities allowed inside any given attribute. You can't just type whatever you want into a database. The domain dictates what is actually valid. Let's fire through some rapid, concrete examples to vividly demonstrate this. Say your column is marital status. Well, the domain restricts entries strictly to married, single, or divorced. If it's a shift column, the domain is just the set of days, Monday, Tuesday, Wednesday. For a salary field, the domain rules that it absolutely must be floating point numbers, say between $0 and $200,000. And for a first name, the domain requires character strings that represent people's names. Domains enforce these really strict boundaries on real-world data entries, also the system doesn't just break down into total chaos.
Now, what's really interesting here is how domains are put into action mechanically. They use data types. Notice how a record ID uses an integer data type. A publication date uses a date type. Author and title, they use text. This is the database actively, physically preventing someone from, say, trying to enter the word pizza into a publication date field. The data type physically blocks invalid data, ensuring that the architectural strictness we talked about at the very beginning remains completely pristine.
So, we've seen the incredible elegance of the relational model, right? How tables, columns, rows, and strict domains create perfect order out of complete chaos. Honestly, it is a massive testament to CF Cod that this 1970s logic still fundamentally structures our digital world today. But as we wrap up this explainer, I want to leave you with a bit of a provocative thought. As our modern world generates massive, and I mean massive amounts of messy, unstructured data, like videos, voice notes, complex AI algorithms, what happens when our data outgrows the strict, neat borders of a traditional table? It's a fascinating question for sure, and it's the exact puzzle driving the next evolution of technology. Thank you so much for joining me to explore the anatomy of data today. Keep learning, keep questioning, and I will catch you next time.